Welcome back to Lesson 2 of Science, Force, and Motion, Part 2. We're going to resume on page 10 of the teacher-made packet. So when forces on an object are balanced, the objects will be at rest. But when they're unbalanced, there's going to be motion. Think about a balanced scale. When it's balanced, there is no movement. When it's unbalanced, there is movement. So let's look at this a moment. If these arms are not moving, what's happening with the forces? If they're not moving, they are balanced. If these arms are moving, what is happening with the forces? They are unbalanced. So reviewing second law of motion is that when forces are balanced, there's no movement. But when the forces are unbalanced, there is movement. So let's think back to years past when we would have field day or in PE when we're playing tug of war. How could a game of tug of war represent Newton's second law of motion? When both sides are pulling equally hard, the rope does not move. If one side pulls harder than the other, the rope moves toward that side. Their unbalanced force causes the rope to accelerate. We've been discussing how balanced and unbalanced forces cause objects to move, and the amount of force affects acceleration. But there's more to Newton's second law. Mass also affects the acceleration of an object. Newton's second law is about describing how forces make an object move and the rate at which it moves. On the bottom of page 10, we have a word web for a word that we've been using a lot the last couple minutes, and that is acceleration. Acceleration is to change the rate or speed of something. So write that in your word web. You may pause the video and then resume. On page 11, what affects acceleration? What will happen if we add a backpack full of textbooks? What will he have to do in order to make it up the hill? By the dot, please write your answer. Did you write that he would have to pedal harder? He would need to pedal harder to be able to make it up the hill if we placed the backpack full of books on his back. Sir Isaac Newton understood that changing the force isn't the only thing that affects acceleration. He also understood that mass affects acceleration. So if you look under the picture of the boy on the bicycle, you will see large force equals large acceleration, small force equals small acceleration. So acceleration is inversely related to the mass of the object. So in the blank, write the word mass, because large mass equals small acceleration, small mass equals large acceleration. And then I would like for you to turn the page. So in this video, we have talked about gravity, that is pulling everything down to the earth, and how is it possible for you to lift stuff. Now, pulling it down to the earth. So how can we go about lifting a heavy box? If the force of gravity has it pulled down, your lifting force must be greater. So make sure that on page 8, I believe it was, of your packet, that you have about Newton's second law, that when two forces on an object are balanced, the object does not move. But when the forces are unbalanced, they move. This is the end of the second Forces of Motion video. Please make sure that you are studying your packets, answering your questions on Google Classroom, and I will see you again when we go over Lesson 3.